Okay. So in the last class, we had seen how to generate AM, DSB, SC, SSB using MATLAB. So in MATLAB, as I said, we will be writing some lines of code. And whenever you execute these lines of code, you will get the output. So you will be writing something like a C program. Okay. So you will be writing all those things using some text. And whenever you run them, you will see the output. So LabVIEW is something different from MATLAB, where you will be using blocks, and by interconnecting different types of blocks, you can generate your required output. So these blocks are called as palettes in LabVIEW. So we will see that how to generate those blocks, or how to place those blocks, and how to play with those blocks so that you can get your AM, DSB, SC. So the two programs that we'll be discussing in LabVIEW is amplitude modulation and double sideband suppressed carrier. So these are the two techniques that we will be seeing in LabVIEW. So in LabVIEW, we will see both modulation and demodulation. Okay, fine. So I hope you are able to see this window. So this is the LabVIEW window. So whenever you open LabVIEW, this is the first window you will see. And the symbol, you can see it here in the taskbar. So it is a symbol, something like a OR gate or some digital circuit gate. So you can see it in the yellow color. So you need to press that, then this window will be open. In this, what you need to do is, whenever you want to create any blocks, you need to go to File and press on New VI. Okay, File, press on New VI. The meaning of VI is virtual instrument. So all the things that you create in LabVIEW are called as virtual instruments. So that is also the reason the extension here is .vi. In MATLAB, the extension is .m. In C, you know that the extension is .c. So every file, or different languages or different programming languages, do have different extensions. So MATLAB is having the extension as .m. C programming is having the extension as .c. And similarly in LabVIEW, whenever you create some block diagram, the extension for that is .vi, where VI is called as virtual instrument. Okay, so you need to press on this new VI. Whenever you press on that new VI, you will see two windows. So this is the front panel and this is the block diagram. So whenever you press on new VI, you will see these two windows. One is called as front panel and the other one is called as block diagram. Okay. So to align these two windows, what you need to do is you press Control T. So whenever you press Control T, okay. So what you need to do is you need to press on File, then within this file, New VI. After this, you will get two windows. So to align these two windows, you need to press Control plus T. So whenever you press these two buttons, Control plus T, the windows will be aligned side by side. Okay, the windows will be aligned side by side. So the two windows that you will get is front panel and block diagram. So using this block diagram window, we will be creating our block diagram. Okay, so if at all you want to create amplitude modulated signal, so you will use this window called as block diagram, where you will be drawing all those blocks and interconnect those blocks to generate AM signal. Okay, so in the block diagram, you will place those blocks and you interconnect them. And what is the purpose of front panel is, you will see the graphs or output. So in MATLAB, we know that the editor is the place where you will be writing the code, and the command window is the place where you will get the outputs. Similarly, in LabVIEW, block diagram is the place where you will be drawing the blocks or interconnect the blocks, and front panel is the place where you will see the outputs. Okay, and front panel is also having one more significance, that you can also give inputs using this front panel. So You also know that using command window, you can give inputs. Similar to that, in LabVIEW, you are having this window called front panel from which you can give inputs and you can also see outputs. I hope you understood the difference between this block diagram and front panel. Now we will be using this block diagram window to generate AM signal. Okay. Fine. So you can see the difference between these two windows. One is like grid shape or having grid. One is not. One doesn't have any grid. Okay. So this is the one which doesn't have any grid is the one we need to use. That is called the block diagram window. Now, as I said, you will be using you will be using palettes or blocks to generate any signal. So to generate AM signal, we already know the equation. So that equation we will be creating with the help of blocks. So these blocks are also called as palettes in LabVIEW. So we will be basically using some palettes to create our signal or to generate our signal. So to generate our signal, what are the things we require? So I'm again writing the equation here. S of t for AM, it will be AC of 1 plus Ka AM sine omega mt cos omega ct. So this is what is the equation. So this we are trying to create with the help of blocks in LabVIEW. So what are the things you need to create or what are the things you require is you require a block to generate this carrier signal. You require a block to generate this message signal and you require a constant block and a variable block. So these are the different blocks you will be using to generate or to create this equation. Okay, so we will be trying to recreate this equation using this LabVIEW. And as I said, you will be only using different types of blocks. So how to get those blocks? Let us see. So you need to right click on this block diagram, right click. Then you will see there are different types of menu from which you can select those blocks. So first what we'll be doing is we will be generating message signal and carrier signal. For that what you need to do is you right click and go to express. Go to express. In this you need to select signal analysis. So I'm again repeating this. You right click on the block diagram, go to express, then in that go to signal analysis. In this, to create signals, you need to use this simulate signal. Okay, this is the block you need to use. You press on this, then you can see that you can move it around. Okay, so you press on that simulate signal and you can move that block anywhere in your window. Now to place this block at some position, you go to that particular position and you again press on left click. Once you click on left button of your mouse, that block will be placed. And once it is placed, you will see the menu. Okay. So what type of signal you want to generate, what is the frequency, what is the amplitude. So let us assume you want to create the message signal. So for message signal in MATLAB, we know that we had taken the frequency as 10 hertz and amplitude as 1. So we will take the same values here. So frequency as 10 hertz and amplitude as 1, and I am taking it as sine signal. Okay. One important point you need to see or you need to look here is this one, the timing. So for our case, you need to keep these two values as 10,000. The samples per second should be 10,000 and this number of samples should also be 10,000. So this is only for better visual representation. Okay, this basically controls your sampling frequency. So FS. Okay, so these are all the details regarding message and this is regarding your sampling frequency. You press OK. Once you press OK, your signal is created. Now you want to rename this. So to rename this, you press on this simulate signal, double click on it. You can rename it. Message signal. Okay. Similarly, we will try to create carrier signal. Right click, express, signal analysis, simulate signal. You place here. Then you can see the details. Since the carrier is 100 hertz, so you take this as 100 and we keep this as sine, no problem. So if at all you want to create cos, you can add this phase. So you add it as 90 degrees phase, you will get it as cos. Okay. Then you need to change this as 10,000 and this is also 10,000. Then you press OK. Okay. Now you rename it. This will be carrier. So the above one is message and the below one is carrier. Now, what are the other things you require? So the other things you require is a constant called 1, and you also need to define a variable called Ka. So to do that, what you need to do is first you will select the multiplier palette. Right click, you go to numeric. So I'm again showing you right click. So in the programming itself, there is a block called numeric. You can see it here, numeric. So in this, you select multiply. You select multiply. Okay. Then to this multiply block, you can see that whenever I move my mouse there are 4 orange points that are visible. Okay. 2 orange points are at the input side and 1 is at the output side. Okay. So there is a small confirmation I want to know whether you are able to see these clearly or not, or you want me to increase the font. Please respond in the chat window. You want me to increase the font or you are able to see those blocks? Okay, so D2 says it is clear. Thank you. Okay, so whenever you scroll on that particular multiplier palette, you can see there are 3 orange points. So 2 are at the input side, 1 is at the output side. So in the equation, you can see that we want to create Ka into m of t, where m of t is the message signal. So to one point of this multiplier, I will give message signal. So how to give that is, you take your mouse to the simulate signal block. Okay. So if you place your mouse here, you can see the mouse is changed, or the arrow of the mouse is changed. So at first it is plus. Now whenever you move it onto this particular block, it is changed to some other shape. Okay. Now you need to click on that particular thing. Left click. Then you can see that there is a line coming out of this. So wherever you want to place or wherever you want to connect this, you can go to that particular point and you can press left click. So I'm again repeating this. Let us assume you want to connect this message signal to one point of this multiplier. So to do that, what you need to do is you need to take your mouse to that particular arrow. So whenever you go, whenever you move your mouse to this particular block, you can see that the sign, the mouse sign is getting changed from plus to some other symbol. Whenever this happens, you can left click on that and then you can left click on the particular point where you want to place this. Okay. Now for the other input point, you need to place Ka. So how to do that is, you go to that particular point, again the mouse symbol changes, you right click on that, create. Since Ka is a variable, you need to create it as control. So in LabVIEW, all the variables are called as control and all the constants are called as constants. Okay. Press on control. You can see that some block has been appeared. And at the same time, in the front panel, there is some value you can see. So if you double click on this particular block, you can see that a value is created in the front panel. The value here, it is by default 0. So since this is Ka, I want to rename this. Whenever you want to rename this, you click on this Y. Ka. Okay. Now that has been renamed to Ka. And the same thing is also reflected in the front panel. Now I want to give a value. So you need to click on that 0.5. So some random value I had taken, don't worry. So Ka into message signal. Okay. Now this should be added with 1 because your equation says that it is 1 plus Ka into Am sine omega mt. I had done this Ka into message signal. Now you need to add it with 1. Okay. To do this, we need to have a add palette. Okay. So right click, go to numeric. In this, there is add palette. Okay. So the first one, you click on that, you place it here. So to this, one input will be coming from multiplier. The other input will be constant called as 1. So to create that, you click on the other input, right click, create constant. So this constant, you can change it here itself. It will not be reflected in the front panel. Double click on that, you type it as 1. So this particular thing basically creates 1 plus Ka into m of t. Now what you need to do, you need to multiply this whole thing with carrier. The carrier here is AC cos omega ct. So to do that, what I will be doing is, I will be again taking a multiplier. And for one input of this multiplier, I will take the output of addition block. And the other input will be going to carrier. I hope you understood the step-by-step process. If you have any difficulties, please let me know in the chat window. Okay. Now you right click on the output of this multiplier block. Now I want to visualize the output of this particular multiplier block. So to visualize that, you need to go to create and click on graph indicator. So you can see that whenever I press on graph indicator, I got a graph in the front panel. Okay. Now whenever I press run, I can see the modulated signal because I had placed the graph at the output of this multiplier where I will be getting the modulated signal. Okay. So if you want to check whether you are getting any modulated signal or not, let us run this. Before running this, you can save the file, but in LabVIEW, there is a provision that without saving the file, you can run. Now you can see some signal has been generated. So since the Ka value is 0.5 and the message signal amplitude is 1, so the overall mu is 0.5. So since mu is 0.5, you will be getting undermodulated signal. So the undermodulated signal can be seen here. So to adjust the x-axis, what you need to do is you need to press on this 1, double click on this one, and you type some value less than 1, 0.5. Now you can see some undermodulated signal has been generated for this particular mu. I hope it is visible to you. So this is what is the modulated signal. Okay. Now you want to see the spectrum of this modulated signal. So for this, what you need to do is you need to take a block called as spectrum analyzer. Okay. That we will be getting it from right click, express, signal analysis. There is a block called as spectral. Okay. Or you can also see the name it as spectral measurements. So you click on that. So you can place it anywhere. So I am placing it here. So once I place this window will be popping up. So I will not change anything. I will just press OK. Now, this modulated signal, I want to see the spectrum of this modulated signal. So for that, what I will be doing is I will click here and I will click on this signal. Now this is connected. Now this modulated signal is fed into this spectral measurement block. Now you want to see the spectrum. For that, you need to go to this particular point and right click, create graph indicator. Okay. I hope you understood the point. So to see the graph, you need to right click on that particular point and then you create the graph indicator. Now, whenever I run this, You can see that on the top of this front panel, the modulated signal is generated, and at the bottom side, the spectrum is there. Since your frequency is around 100, because the carrier frequency is 100, and the spectrum here is showing till 5000. That is the reason you are only seeing a single peak. So to clearly see this, what you need to do is you need to click on this 5000, double click on that. Then you give value like 250. Now you can see there are three peaks. So what is the significance of these three peaks? In AM, you will be having three peaks. One is at the carrier. So you can see the carrier is at 100, then upper sideband and lower sideband. Okay. So this is how you can visualize the spectrum of modulated signal. Then you want to demodulate this. So to demodulate this amplitude modulated signal, I am going to use coherent detection. So in coherent detection, the principle is you will be using the carrier same as that of the carrier used at transmitter side. So in the transmitter side, whatever the carrier you had used, that will be used at the receiver side, and with the help of this carrier, you can demodulate it. So that I will be quickly showing you how to do that. So the parameters you need to give same as that of the carrier used at the transmitter side or at the modulating side. So wherever you are performing this modulation, you are using some carrier. So that particular carrier is again need to be used so that you can demodulate your message signal. Okay. So you know that in coherent detection, you will multiply your modulated signal again with the carrier, and this particular thing is passed through a filter. Okay. So I'm again repeating this. In coherent detection, you will multiply your modulated signal with carrier, and you pass this particular signal, which is multiplied with carrier, through a filter, that is low pass filter. So whenever you pass through this low pass filter, you will get back your message signal. So I had multiplied it with carrier, and then I will be passing it through a filter. So the filter can be obtained from Express Signal Analysis. There is a block called as filter. Click on this filter, place it here. So the only thing you need to change here is cutoff frequency, because your message signal is around 10 hertz. So you use the cutoff frequency near around 10 hertz. So I'm using around 15 hertz. Okay. So except that, don't change anything. Now you need to feed your signal, which is multiplied with carrier, to this particular filter. Then at the output side, you will get your demodulated signal. Right click, create graph indicator. I hope you are able to see the filtered signal. So whenever I run this, so the signal that I need to get it is a simple sine wave or a signal which is similar to that of the message signal. So you can see that you are getting your sine wave back. Now, how to know whether this is same as that of the message signal or not? So for that, what you can do is you can also plot the message signal. For that, you right click on this particular wire. So whenever you move this particular mouse to that particular wire, you can see that it is getting converted to plus to arrow. Okay. So you right click on that, create graph indicator. So now you can see that a particular graph indicator is created. So this is the one. And this is basically the representation of your message signal. Now, whenever you run this, so you can see that it is same as that of your message signal. So there will be some difference at the start of the signal. So ignore that. The overall number of cycles will be same as that of your message signal. So as I said in MATLAB also, so there will be some shift in your demodulated signal. The main thing you need to look into is whether your demodulated signal is having same frequency as that of your message or not, or whether the shape is also same as that of your message or not. The amplitudes may get changed, and there may also be some shift in your demodulated signal. Okay, I hope you got the point how to create the blocks to generate AM signal. Okay, if you have any doubts, please let me know. Sorry. So this is how you will create your, or you will generate AM using LabVIEW. Okay, now I will show you the AM generation block. Okay, please give me a minute. So the same thing I had already created and I had saved it with the name as AM. Okay, the only thing is I had labeled it properly, so that you can easily understand. Okay, so you can see here message signal carrier, and I am plotting that message signal and carrier in the front panel. Then these things are passed through the spectral measurements so that you will get the spectrum, and I'm also plotting the modulated signal. So this is same as that of the one that I had shown you, but the only thing is I had properly labeled them so that it will be easy for you to understand. Now whenever I run this, you can see that there are 5 different types of graphs. Okay, give me a minute. Okay, so the point here is the Ka value is 0. So that is the reason your demodulated signal is not properly visible. So you need to keep this in between 0 to 1 to get under modulated signal. So I am keeping this as 0.7. And whenever I press run again, now you can see that everything is proper. Okay, here let us suppose you had created a graph and you are unable to see that graph in the front panel. So to see that, what you can do is you can double click on that graph indicator created in the block diagram. So let us assume you want to see the graph of this message signal. You double click on this. Now you can see that whenever I double click on this, that will be highlighted in the front panel. Okay, so this is message signal, this is carrier. Now then this is modulated signal. Since I had given a Ka value of 0.7, you will get the under modulated signal. Then this is the demodulated signal, which will be same as that of your message. And the final one is spectrum. Now again the same thing, you need to adjust these x-axis values so that you can clearly see the spectrum. You double click on this 5000, then type 250, you can see the spectrum. Similarly, to see this modulated signal in a better way, double click on 1, 0.5. So it is up to you. So you can change this to have a better clarity. Okay. Similarly, you can do this for critically modulated and over modulation also. For critically modulated, I'm giving Ka as 1. You run this. Again, you can adjust this. So this is critically modulated signal, and this is the carrier. Okay. Similarly, you can do this for over modulated signal. You double click on this one. So you can see that there is a crossover happening. There is some minor lobe type of thing that is appearing whenever I am giving this Ka as greater than 1. And this is your carrier. So any doubts till this point, please let me know. So everybody understood how to create blocks or how to join those blocks to create your AM signal. Yes or no? Somebody respond in the chat window so that I can continue. Okay. J1, thanks for the response. So we will see the next particular experiment, that is DSBSC using LabVIEW. So how to generate a DSBSC signal using LabVIEW. So this is very simple and easy since you had understood how to generate AM using LabVIEW. So DSBSC generation and demodulation is very similar to that of AM and also easy to understand. Now the equation that we will be using to generate DSBSC is S of t is equals to AC cos omega ct into AM sin. So again, I'm repeating this. You can take any form of signal, that is, you can take sine or cos. But for your understanding, I'm taking message as AM sin omega mt and carrier as AC cos omega ct. Okay. So this is the equation you will be implementing in the LabVIEW to generate DSBSC signal. Oh, sorry, I forgot to share this. Okay. So in DSBSC, this is the equation that you will be using, and using this equation, you can create your DSBSC. So based on this equation, you will use those blocks and you join them so that you will get this DSBSC signal. Okay, so the two signals that you require is carrier and message, and there is a multiplier in between this. Now we will go back to the LabVIEW and see how we need to do this. Okay. So I will keep all other things same. So I need to just remove this. So, okay, whenever you see this type of cross marks, you need to remove them so that you can properly run your VI or virtual instrument. So, how to remove them? You need to click on that cross mark, then press on delete. Cross mark delete. Okay. Now, what you need to do is you need to join this message here. So, why I'm doing this? In DSBSC, we know that a simple multiplication between message and carrier can produce my DSBSC signal. So that is the reason I had removed all those blocks and I had simply joined it to the multiplier. Now I want to see the message signal. For that, I will be joining done. Now you run this. Okay. So you can see it here. So this is your DSBSC signal. Okay. And this is the spectrum of that. So there are only two side bands. So there is no carrier. Okay. So the carrier frequency is 100 hertz, and you can see that there is no peak at the 100 hertz. That indirectly represents the carrier is suppressed. So there is only upper sideband and lower sideband. So one is at 110 and one is at 90. Okay. And this is the modulated signal and this is the message signal. So you can see that the modulated signal is properly obtained. So what we had done is we had kept all the blocks same and we had just removed some blocks which are unnecessary depending upon the equation. So in the equation, we can see that the message and the carrier are the only things we require to generate DSBSC. Okay. So I'm again repeating this. So if you know AM code in MATLAB, you can easily get DSB, and FM. Similarly, if you know the block diagram of AM in LabVIEW, you can easily recreate DSBS. Okay. So I will show you one more VI which I had already created. So this is the same thing, but I had named them and I had placed them in a proper way so that you can see it in a clear manner. When I run this, so you can see that message signal carrier is generated, and this is the modulated signal. This is filtered signal, which is nothing but your demodulated signal, and this is your spectrum. You again need to change these x-axis values to clearly see your spectrum and modulated signal. So I hope you are able to see all these signals. And one important point is there is no need of any Ka because your equation doesn't have any K. DSB-SC generation is very simple. You just need to multiply message and carrier. So that is the reason we don't have any Ka here. Okay. Okay. So any doubts regarding how to get those blocks or how to connect those blocks to get the required output? LabVIEW is much easier than your MATLAB version because in MATLAB you need to type things and you need to check whether you had properly typed or not. But in LabVIEW you just need to place those blocks and you interconnect those blocks. So in my view, LabVIEW is much easier when compared to the MATLAB. Do you want me to repeat any particular thing? Please let me know in the chat window so that I can repeat that